Okay, the previous video we covered decomposition method, which is one way to model seasonality. I'm going to give you another way, and neither one of these are in the book. And like I said earlier, there's many different forecasting methods. Knowing which one to choose, we'll talk about that when we talk about forecast accuracy. But there's different ways to predict the future. So the decomposition method is also called a multiplicative method because we multiply by seasonal index. Another way is an additive model where we just add a bump attached to it. And we're going to do that using multiple regression. So I'm going to go back to that problem that we just did. And I'm going to create a copy and then get rid of all this other stuff that we've done. Okay, so this is the original problem. And remember what we have based on my pattern is I've got a seasonal, I've got a seasonal index as well as a trend. So I'm going to use multiple regression to attack that. Now, part of where multiple regression exists is under the Data tab, Data Analysis, Regression. But the trick is we're going to use binary variables to represent the quarters. And the rule on how you use binaries is that if you've got, in this case, 4 different quarters, I would need to have 3 binaries to represent it. If I was modeling, these were days, and I had 7 days, I would need to have 6 binaries. You always need to have one less binary variable to model. And you've got to set up a mapping scheme, and it's a pretty easy one. All I'm going to do is, I'm going to use column F. You're going to see, well, I'll use column E. And this is going to be the binary variable for quarter 2. And this is going to be a binary variable for quarter 3. Binary variable for quarter 4. When I say binary, that means it's going to take on a value of 0 if that's not the case, or 1 if that's the case. So this very first one, that's quarter 1. Well, is that quarter 2? No, so I put a 0, 0, 0, and I don't need any of these to show any decimal points. Just whole numbers. There. So in the very first quarter, the very first row, it's a quarter 1. Since that's a quarter 1, that does, all of these are 0. And all that means is that my interpretation is that if I see a bunch of zeros, that's quarter 1. But the next one, it is a quarter 2, so that becomes a 1, and these are zeros. And the next one, quarter 3, and then the last one, let's get rid of this. So this pattern then repeats. And all it is that you're using bits or binary logic to represent categorical data. So quarter 4 means it's the 4th quarter. How you would represent that in bits or using binary logic is I would say 001. And if you heard 001, you say, oh, that's quarter 4. And all this does is it just repeats. It's just a repeating pattern because we've got every quarter for the last 6 years. And I'll go ahead and go out into the future like that. And don't forget, we also have a time period. We have a time index, and that is this number. And there's a reason I'm reproducing it. I'm trying to put all of my independent variables together. So now that I've done this, I've got what really happened. That's going to be my dependent variable, or my y, and then I'm going to have 4 independent variables or inputs. This one, this one, this one, and this one. So I go under Data, Data Analysis, Regression, and it asks me, what is my y range? Well, when you do regression, you only have one column. You only have one y when you do traditional regression. So that's column, that's my call volume residing in column D down to row 25. And then my X range has to have the same number of records or same number of rows. So, but I can have more than one. That's what makes it multiple regression. So look what I've done. Y range is column D. X ranges are E through H. They have to be adjacent. I can't have independent variables here and over there. That's why I reproduced the time index or the time period. I reproduced A over an H. The very first row is labels. It's not data. D1 is not numbers. It's an identifier. And then I'm going to let it generate a new worksheet where it puts the output. So that's why new worksheet range. When I hit OK, down at the bottom I get something called sheet 2. Now regression analysis you've probably done in your stats class or your big data class, but just as a refresher, one of the first things we look at is that how good is the model fit. We're looking for high R-squared numbers. That's almost stupid high. That's probably not going to happen very often that you get a number that high, but that's a really, really high fit. So that's good. The most important thing is that we've got these become my coefficients. These become what I need to multiply by the independent variables. So I'm going to grab these and I'm going to copy them. And I'm going to go back to my data and I'm going to scroll down a little bit, but I'm going to put it right there. I'm going to do a paste special and I'm going to transpose. And let's make these a little bit bigger. So now when I start predicting the future, which is what I want to do in column I, this will be my forecast. How do I generate the forecast? Is I'm going to take the intercept plus this number times this number plus this number times this number plus this number times this number plus this number times this number. It's the intercept plus, in the formula I'm going to use in Excel to do these sum of some products is something called the sum product. The sum product formula lets you multiply vectors or arrays of the same dimension. So in this case we have a 1 row by 4 columns for my inputs or before my coefficients, and then I separate them. They're going to get multiplied by these 1 row by 4 columns. Now I'm going to copy this formula down, so all of my references to over here on the right, I need to put some dollar signs around it. But that becomes my future. Well, there you go. That's how you can forecast the future. We did not use the decomposition method. We did not calculate a seasonal index in terms of a multiplier. We generated a bump attached to that. So you can see the bump. These are what these are for quarter 2, 3, and 4, where quarter 0 is kind of the base. So if I would just look at these numbers compared to what I did prior, 756, 807, this is what I did prior. I had 703, 792, so that's one forecast, that's the decomposition method, and now we just generated another set. So if I would forecast using this one, put it on a graph. There you go. Now that's using multiple regression. Now personally, I think this is not as good. This one doesn't look as, to me, makes more sense to use the decomposition method. This one looks like more sense to me. Again, just using my ability to see patterns, this one doesn't look like it is as big or as extreme as it should be. But that's using just eyesight. How do we know? How do we have some confidence that our models are more accurate? So how would we choose between the decomposition method and multiple regression? Well, that's when we start talking about accuracy. We need to be able to model accuracy. So the next video we'll be talking about forecast accuracy. Thanks.